Hello folks, my name is Georgios Papadopoulos and welcome to this video on Spanning Tree Protocol, a 4-step process. As you might know, there are different types of Spanning Tree Protocol. In this video, I will focus on the IEEE 802.1D version, which is the original version of the standard. Please keep in mind that the main purpose of STP is to prevent switching loops in Ethernet networks. According to the STP, the switch with the port in blocking state will continue receiving the frames, but it is not allowed to forward them. Now, toward this aim, STP follows a strict process to identify which port to block. And it consists of 4 elementary steps. During the first step, one switch will be elected as the root bridge in the network based on lowest bridge ID. Now, the root bridge is the central point of a network. The bridge ID is the concatenation of the bridge priority and the MAC address. So, in this example, the switch with the lowest bridge ID or BID is the switch A since it comes with the lowest MAC address. Except the root bridge, all remaining switches of the network are considered as the non-root bridges. In the second step, each non-root bridge will select its root port. The root port is a port on a non-root bridge that is closest to the root bridge. In other words, the port with the lowest root path cost value. The path cost is a value associated with the link speed or bandwidth of the links between bridges. In this example, we have links of fast Ethernet and gigabit with 4 and 19 path costs respectively. Now, the root path cost is the cumulative cost of all links to the root bridge. Therefore, both non-root bridge switches will choose their root port, the port that directly connects them with the root bridge, since they are coming with the lowest root path cost value. Now that the network has selected its root bridge and the non-root bridges have selected their root ports, the third step of STP consists of selecting the designated ports. A designated port is the switch port that has the lowest root path cost value on a given network segment, meaning per link. For example, between switches A and B, or between B and C. Note that designated ports exist both on root and non-root bridges. Now, all ports of the root bridge are designated ports. Why? Because the root bridge has no cost to reach itself. Thus, it always has a value of 0. On the other side of the links, switches B and C are connected to the root bridge on a gigabit and fast Ethernet interfaces. Therefore, their root path costs are 4 and 19 respectively, which are higher than 0 cost of the root bridge interfaces. And this is why they are selected as designated ports in this segment. Finally, on the shared network segment between switch B and C, a designated port needs to be selected. Switch B has lower root path cost to reach the root bridge. Indeed, 4 is lower than 19, and therefore its interface is selected as the designated port for this segment. Now, the final step, step 4, consists of selecting the non-designated ports. A non-designated port is the switch port that has the highest root path cost value on a given segment. In practice, a non-designated port has no role to play and it is marked as the blocking port and thus it is not allowed to forward traffic in order to prevent a network loop. And that's all, folks. I hope that you have enjoyed the video. Thank you for watching and see you on the next video on Spanning Tree Protocol.